These are the scientific shocks that changed how we see reality. And once you see them, you can't unsee them. Science is supposed to explain reality. It gives us laws, principles, and a framework to understand the universe around us. But some discoveries did the complete opposite. They didn't just add to our knowledge, they shattered it. They shocked scientists, broke all expectations, and some still don't entirely make sense today. From the quietest place on Earth, where you can hear your own blood flowing, to experiments where the simple act of observing something changes reality itself. These are the scientific shocks that have fundamentally altered how we perceive everything. Let's start with a question. What's the quietest sound you can imagine? A library? A remote forest at night? What if I told you there's a place so quiet, it can drive you mad? Welcome to the anechoic chamber. The word anechoic literally means without echo. These rooms are designed to absorb over 99.99% of sound. The walls, floor, and ceiling are covered in sound-absorbing foam wedges, creating an environment of almost absolute silence. Microsoft built the quietest one on Earth, and it's a truly bizarre experience. When you step inside, the silence is deafening. You stop hearing the outside world and start hearing your own body. You can hear your heart beating, your lungs breathing, and even the gurgling of your stomach. Stay in there long enough, and you might even hear the blood rushing through your veins. The longest anyone has managed to stay inside is about an hour. After that, the sensory deprivation becomes overwhelming, causing disorientation and hallucinations. This chamber reveals a shocking truth. Our brains are constantly filtering out the noise of our own existence. In total silence, that filter disappears, and we are forced to confront the symphony of our internal biology. It's a reality we're never meant to hear. Now, let's move from the world of sound to the world of motion. We perceive reality as a smooth, continuous flow. When you watch a bird fly or a ball roll, it looks seamless, right? Well, high-speed cameras tell a different story. They reveal that at a microscopic level, reality isn't smooth at all. It's a series of tiny, distinct moments strung together, like frames in a movie. Think about a drop of water hitting a surface. To our eyes, it's a simple splash. But a high-speed camera captures an incredibly complex dance. It shows the droplet deforming, flattening, and then exploding into a beautiful crown-like shape, all within milliseconds. Or consider a hummingbird. To us, its wings are just a blur. High-speed cameras show us the intricate figure-eight pattern they trace in the air, a feat of aerodynamics we could never appreciate otherwise. This discovery is shocking because it implies our perception of a continuous now, an illusion created by our brain. We don't see reality as it is. We see a simplified, smoothed-out version. The universe, at its most fundamental level, might be more like a digital video than an analog film. Every moment is a distinct frame, and what we call time is just the progression from one frame to the next. But if that bends your mind, our next topic will break it. Get ready for the double-slit experiment. This is perhaps the most famous and mind-boggling experiment in all of physics, and it strikes at the very heart of what reality is. Here's how it works. Imagine you have a barrier with two thin, parallel slits in it. On one side, you have a machine that shoots tiny particles, like electrons, one by one, toward the barrier. On the other side, there's a screen that detects where the electrons land. Now, if electrons were like tiny marbles, you'd expect to see two distinct lines on the screen, corresponding to the two slits they passed through. Simple enough, right? And when scientists first did this, that's exactly what they saw sometimes. But here's where it gets weird. When they didn't watch which slit the electrons went through, the pattern on the screen changed completely. Instead of two lines, an interference pattern appeared, a series of multiple bright and dark bands. This is the pattern you get when waves, like light or water waves, pass through two slits and interfere with each other. This meant that each individual electron was behaving like a wave, passing through both slits simultaneously and interfering with itself. Think about that for a second, a single particle into places at once. But the shock doesn't end there. The scientists decided to peek. They placed a detector by the slits to see which one each electron actually went through. The moment they started observing, the interference pattern vanished. The electrons went back to behaving like particles, creating just two lines on the screen. It was as if the electrons knew they were being watched. The very act of measuring or observing the particle forced it to choose a single path and abandon its wave-like nature. This is the observer effect, and it's a cornerstone of quantum mechanics. It suggests that at the quantum level, reality isn't a fixed, objective thing. It exists in a state of probabilities, a cloud of possibilities, until a conscious observer interacts with it. Observation doesn't just measure reality, it helps create it. We are not passive spectators of the universe. We are active participants in its unfolding. No one fully understands why this happens. It challenges our most basic assumptions about cause and effect, and the nature of existence itself. From the impossibly small, let's look out to the impossibly vast. In 1977, an astronomer named Jerry Ammon was using the Big Ear radio telescope to scan the cosmos for signs of extraterrestrial intelligence. The telescope was pointed at a group of stars in the constellation Sagittarius. Suddenly, the computer started printing a stream of characters representing a powerful, narrow-band radio signal. The signal was so strong and so unusual that Emin circled it on the printout and wrote one word next to it: wow. The wow signal, as it came to be known, lasted for 72 seconds. It was exactly the kind of signal that astronomers expected an alien civilization might use to communicate. It was strong, concentrated at a very specific frequency, and it appeared to come from deep space. The frequency was near 1420 MHz, the same frequency at which hydrogen, the most common element in the universe, naturally radiates. This has been called the watering hole of the cosmos, a logical frequency for any intelligent species to use for interstellar communication. Here's the shock: after that initial 72-second burst, the signal was never detected again. Astronomers have pointed countless telescopes at that same patch of sky for decades, but have found nothing. It was a one-time cosmic whisper. Was it a natural phenomenon we don't understand? Or was it a genuine, fleeting message from an alien intelligence? We may never know. The wow signal remains one of the greatest unsolved mysteries in science, a tantalizing hint that we might not be alone. And finally, from the quietest place, let's go to the coldest. We all know absolute 00 Kelvin, or minus 273.15 degrees Celsius, is the theoretical point where all atomic motion stops. It's the ultimate cold. Scientists believed it was impossible to reach, let alone surpass. But in a lab, they did something that seems to defy the laws of physics. They created a gas of potassium atoms and used lasers and magnetic fields to cool it to just a few billionths of a degree above absolute zero. Then they did something clever. They quickly flipped the magnetic field, which caused the atoms to rearrange their energy states. The result: for a fleeting moment, the atoms achieved a temperature below absolute zero. Now, this doesn't mean it was colder than cold. Negative Kelvin temperatures are actually, bizarrely, hotter than positive infinity. Think of temperature as a spectrum. It goes from just above zero up to infinity, and then wraps around to negative infinity, approaching zero from the negative side. These negative Kelvin systems have strange properties and could help us understand mysterious cosmic phenomena like dark energy, the force that's causing the universe to expand at an accelerating rate. Creating something colder than the coldest possible temperature is a profound shock, showing us that even our fundamental definitions, like temperature, can behave in ways we never imagined. And the most unsettling part: science hasn't answered all of these yet. The double-slit experiment, the wow signal, these are not settled science. They are active, baffling mysteries. Reality is stranger than fiction, and we're only scratching the surface of understanding it. If this shocked you, there's a lot more coming. Watch the next video and subscribe for more weekly scientific shocks that will change the way you see everything. Thanks for watching.